Today's lesson is on section 8.10. This is the last and final section in chapter 8, which happens to be the longest chapter in our textbook. This combines a little something that we learned back in like November and December in chapter 8. I'm sorry, not chapter 8, chapter 4 and chapter 5. We had did graphs of lines with y equals mx plus b, slope-intercept form, all that fun stuff. And then in chapter 5, we did systems of equations. Specifically, we did systems of linear equations. You were always only given two linear equations back when we did substitution, elimination, and graphing in that chapter when we did systems. Well, now they want to introduce nonlinear systems. All that means is you are going to have one of the two equations is going to be quadratic. One quadratic, one linear. For us, that's as crazy as we're going to get. When you get up in upper levels of math, you might be graphing two other types of equations, or maybe you're going to graph 5 different types of equations and they're all going to be different shapes and you want to see where they intersect. We're not doing that. We're just simply going to do parabolas and lines. So there are 3 different scenarios that you might have. The first one is where you'd have no solution. This is where it's not about where does it cross the x and y axis. So notice in these 3 pictures, there's not even an x and y axis drawn because it's not about where does it cross the x axis, which is what we've been doing all chapter long. The question is, where do the parabola and the straight line, where do they intersect? And in this first circumstance on the left, they never touch. This would be an example where your answer is no solution. The second situation is where you have a straight line and a parabola. They only intersect at one place. Now, I know it's kind of hard to see, but there is as if there is only one intersecting point somewhere on that parabola and that line. They didn't do a very good job. The editor from the textbook should have zoomed in on where that intersection happened so you can clearly see that the straight line, being that the straight line is not curved, it can't touch the parabola in more than one place. It just kind of grazes it on the outside. They just should have zoomed in on that picture a little bit more. Your third scenario, it is pretty clear on this one. You have 2 significant intersecting points, as if that green line cuts completely through the parabola, creating the 2 points. Now, back in chapter 5, we went over 3 different ways to solve solutions. We did solving systems. We did graphing, substitution, and elimination. I gave you a quiz just on graphing and I forced you to graph. Then I did one on substitution where I forced you to show me all the work to show me substitution. And then there was one on elimination. Well, frankly, at this point in time, a lot of the questions are going to be multiple choice. Therefore, you can use whichever one you like best. Your calculator is going to fall under the category of graphing. So you can use that as long as you know how to use that. There are certain buttons that you need to know how to push and things like that rather than just using the graph. So we're going to start off with graphing and substitution in this video, and I'll finish up with a second video on elimination. So the first example we're going to do is where we're just going to use a graph. Going old school on us, and we're just going to use a graph. This may not be a favorite choice of people if you don't remember how to graph the quadratic equation. So again, you are going to be given one quadratic equation and one linear equation. So this top one is the quadratic equation. I know this because there's an x squared in the equation. And then the one that doesn't have the x squared is going to be our linear equation. So let's start with the quadratic equation. In order for me to graph this, the first thing I need to do is I need to work on the vertex. By working on the vertex, I also, at the same time, consequently, I get the axis of symmetry. So when I plug in my b value, which is -2, -2 over 2 times 1. It's going to give me 2 over 2, which is at 1. So even though you don't have to draw the axis of symmetry, it does help in order for you to mirror points onto the left or the right-hand side of that axis of symmetry. So now once I have that x value of 1, to get the y value, which will be of my vertex, I'm going to plug in the 1. 1 minus 2 minus 3. -1 minus 3 is -4. Okay, so my vertex is at 1, -4. So it's going to go right here. Now, the second point that's rather easy is going to be your y-intercept. Your y-intercept, if you remember, is your c value. So I'm going to put a point at -3. Now, this allows me to mirror the 1 point over to the right, because that one, the -3, was 1 away from the axis of symmetry. Now, even though I do know that this is going to go somewhere upwards like that, I need to be a little bit more specific. I don't have enough points. No one's over you telling you have to have 5 points or you have to have this number of points. I just don't have enough information yet to really decide where this is going to intersect. So I'm going to do 1 more point. I'm going to choose to do you can pick -1 or 3. I'm going to go with 3 because I'd rather deal with the positive than the negative. But you can pick either one. So it gives me 9 minus 6 minus 3. 3 minus 3 is 0. That's going to give me a point at 3, 0. So I'm going to plot that point. That's 2 spaces away from the axis of symmetry to the right, so I'm going to go 2 spaces to the left. Now I'm going to draw that in. If I need more points, I'll do more points later. Okay, again, the 2 points that I just plotted, 3, 0 and -1, 0, those are solutions to the parabola. I don't want the solutions to the parabola. I want the solution. I want to know where does the line and the quadratic equation of the parabola intersect. So the next one that I'm going to do is now I'm going to do this linear equation. Y equals -x minus b. Now, if for some reason it wasn't already where y was by itself so that it falls perfectly into slope-intercept form, I would rearrange it so that it would be in slope-intercept form. So your m, or your slope, is the number that's in front of x, which is -1, and my y-intercept also happens to be -1 in this one. So I'm going to go plot those points. I've got a point at -1. Now my slope is down 1 over 1, down 1 over 1. I can see where one intersecting point is going to be, but I need to get the other one in the other direction. So I'm going to go up and over 1 in that direction. Connect the dots, basically just to make it look pretty. But your 2 solutions here, which you can see you have 2. You have one here at 2, -3, and the other one is at 1, -1, 0. So again, this one over here is at 2, -3, and then this one is at -1, 0. Those are my 2 solutions. They are -1, 0 and 2, -3. Now, to check my answer, this is a bit of a pain in the butt, but so the way that we would go about checking it, at least without the calculator, without using the graphing function on the calculator, this would just be a matter of plugging each of these points in. So in this first one, I have the quadratic equation. In this one, I plugged in -1, 0, -1 for x, and 0 for y, and it checks out. Then I go and I plug the second point, 2, -3. 2 into x and -3 in for y, and that one works out. And I'm only halfway done because now I got to do the same 2 points for the other equation, for the linear. You have to go, in order to truthfully and 100% confirm and check your answer, you do have to go through it 4 times. Twice for the first point and twice for the second point. You have to be able to plug in both points into each equation. It is time consuming. However, if your life depended on it, if it was something really important, a grade on a quiz or a test or an SAT question or something along those lines, you would want to go through and check your answer. Now, I'll show you how to do it on the calculator in a second. That's going to be a second way to check it. So while this seems very tedious, if you can remember how to type it in your calculator, you can use that as a checking mechanism as well. So the second question I'm going to do using the calculator. So for this problem, again, I've got a quadratic equation and I've got the linear equation. I know that this first one's quadratic once again because I've got the x squared in it. So your step 1 in the calculator would be to type the 2 equations in. So you're going to press that y equals button in the top left-hand corner of your calculator. Type in the 2 equations. Double check that you got everything correctly. Make sure that plot 1, plot 2, plot 3, nothing is highlighted. If it gives you an error in the next step, then that means that you have to go back to see if it ends up being that you have something typed in correctly. That would give you an error message. Now, for the second step, you are going to press the graphing button, which is the top right-hand button. This isn't going to exactly give me my answer. It's going to give me a rough estimate of my answer. But what really is important is the fact that it's going to let me know I have 2 answers. I can clearly see this is going to be one of those scenarios that I have 2 answers. So now I got to be positive of those 2 answers. So I am going to use the table key. So the third thing that you're going to do is go to the table key. And you're going to get there by pressing the second key and graph. Now, once you're here, you are going to try and find, now that I know that there are 2 solutions, I need to see where those 2 y values are the same. So I'm going to go down the list, and as you can see right here, I have where they're both 2s, and down here I have where they're both 5s. That means those are going to be my 2 answers. I'm going to have one at 1, 2, and the other answer is at 4, 5. Those are my solutions. So this is much quicker than having to go through all that graphing and plotting all the points and remembering how to find the vertex and the axis of symmetry. It is a lot quicker, but you do have to remember those steps on your own. Now, being that I used my calculator for this, the 1, 2, and the 4, 5 to check, I would have to go to be confident about the answer. I would have to go through this whole process. A lot of people are gonna be like, I'm just going to put that answer down. They don't even feel like checking the answer. But again, if it was very important, this is how you would check your answer. Obviously, if you had enough time to do that. The way that I just showed you in the calculator to get the answers, we could go back and we could do the same thing for this question. Instead of plugging all this information in here, I could check -1, 0, and 2, -3 from the table for this as well. So you can use that to check your answers if you wanted to, or if you remember how to type it into the calculator. Okay, now we're going to move on to substitution. We're going to do 2 examples of substitution. Okay, for substitution, you wanted to do substitution when you have at least in one of the equations, a variable by itself. Usually it's going to be y, because that's how we want our quadratic equations to be and our linear equations, so that way they're set up for us to work with. So in this equation, I'm just going to take one and I'm going to plug it into the other here, basically setting the 2 equations equal to each other. Now, once I'm here, I'm going to combine my like terms, subtract x, 2x squared minus 4x plus 4 equals 2. Next, I will subtract 2. Now, if you're fancy, maybe you could have done that all in one step, and that's fine. I just was dramatic by doing it in 2 separate steps. Now, you have to decide how you want to solve this quadratic equation. You could graph this. You could factor this. You could use the quadratic formula if you wanted to. You could pick any way that you want that you're comfortable with solving. This doesn't work for square roots. You could also do completing the square root. That's another way that you could have done this. The only one that doesn't work is square roots. So you could graph, you could complete the square, you could factor this, you could do the quadratic equation. Okay, I am in the mood to factor. So that's what I'm going to do. So I'm going to factor out of 2. So I have x squared minus 2x plus 1. From here, this is going to factor to become x minus 1 and x minus 1. What this means that I have the same thing twice is that this is a circumstance where I only have one answer, and my x value is 1. So I could, now I'm going to take that, because my final answer, I'm only going to have 1 point as my answer. I'm going to take that 1 and I'm going to plug it into one of these 2 equations. Personally, I think that the linear equation is much easier to plug it into. I could almost do that in my head. And I get 1, 3 as my coordinate point. So now you could check yourself. Do you want to check yourself this way? It wouldn't be as long because I'm only checking one point. So I could plug it into each of the two equations. Or do you want to use the graph in calculator in order to plot the 2 points and plot the two equations and look for the one significant point? You can pick whichever way you want to check your answer. If you have time, that's how you can check your answer. Now, second example, I'm going to again take this first equation, plug it in for y in the second equation, which is essentially you just setting the two equations equal to each other. Once again, I'm going to work on this to get x by itself. I'm sorry, not get x by itself, but to move everybody over to one side of the equation. Now, my 3x's canceled out, so I'm left with 3x squared minus 3 equals 0. Now, again, you need to make the decision. Do you want to do graphing, factoring, completing the square? Do you want to do quadratic formula? Personally, I think factoring would be an easy one on this because you would factor out the 3, and then this is the difference of two squares, and I would be done. But since I just did one with factoring, we'll go ahead and we'll do one with the quadratic equation. Just for fun. Because you know the quadratic equation is super fun. Now I don't have a b value. Remember that when there's no b value, your b value is 0. And my c is -3. Alright, so I have x equals the opposite of b plus or minus the square root of b squared minus 4 times 3 times -3 all over 2 times a. Alright, there is no such thing as being an opposite of 0, so it's just 0. And this becomes plus 36 because the 3 is negative. So next I have x equals plus or minus the square root of 36 over 6, which would be plus or minus 6 over 6. 6 over 6 gives me 1. And -6 over 6 gives me -1. So those are the x values. This happens to be a problem where I have two solutions. So now what I have to do with those 1 and -1, I have to come back up here and pick either of the two equations. Again, I like the linear equation better. And I'm going to plug in the value of 1. And I get -1. So that means this point is at 1, -1. Oh, I'm sorry, it's 1, +1. Okay, 1, +1. And then the second one, I'm going to plug in -1 to this one. 3 plus 4 is 7. So I get my answer. My second point is at -1, +7. So these are my two answers. Again, if you want to check, it's totally up to you. You could either use the calculator to solidify and confirm that you have two answer points by using the table, or you'd have to go back all the way up here and do this. This would be one of those tedious ones. You'd have to do it 4 times because there are 2 points and 2 equations. So in our next video, I'm going to go over solving by elimination. But that's it for today.